All right, I want to use this example to point out a couple things. And so what I'm about to talk about is there's more than one way to think about writing these equations. All right? They're all mathematically equal. So when you've tried all of them, pick the one that is your favorite, that makes sense to you, that you can consistently apply that method, right? Because they're all the same mathematically. All right, so what I initially said is the ones that we're entering were positive, and the ones that we're leaving were negative. Okay? That's one way of doing it. Entering minus leaving equals 0. All right, so I'm going to write that over here. Entering minus leaving equals 0. You can see mathematically that that's the same as entering equals leaving. So I could have put all the entering ones on one side and then the equal sign, and then used positive signs and all the leaving ones on the other side. So I'm going to belabor this and put a plus in front of the entering and plus in front of both of these. So we treat them both as positive, entering equals leaving. All right, there's another way to do this where you could draw your arrows so that they're all entering a node and all positive. All right, so you would have basically the sum of the currents equals 0, where you would treat all of them as entering the node. You would draw all the arrows, into the node. All right. So a node would look like all the arrows coming in, and they would all be positive currents. We could do the same thing where they're all leaving. Yep. All leaving a node, not anode, and they're all positive. So the sum of the currents is 0. And we would draw all the arrows leaving the node, out of the node. So that picture, we would have all the arrows going away, and they would all sum up to 0. All right. So you can see from my math up here where I said they were all leaving, and by my first logic that leaving is negative, I put a minus sign in front of all of them, and they sum up to 0. So one of the signs needed to switch, right, in order to add up to 0. So we found out that I2 was negative 10, which means on our picture, we guessed an arrow to the left. We found out it's negative 10. So 10 milliamps going to the right. It doesn't matter, though, as long as the picture and the math agree with each other. And you can see mathematically, if I went through this equation and multiplied by -1, so I went plus, plus, plus equals 0, I'm going to get the same answer. So mathematically, it's identical. Right. So what I have found teaching this many years is that there's going to be one of these techniques that's going to stick for you. All right? And we're going to use this technique again in another chapter and forever after. We're going to use nodal and mesh analysis that use these techniques, KCL and KBL. So you're going to, there's a reason to learn this and have a habit with it. So either entering minus leaving or entering equals leaving or treating them all entering or all leaving. One of these is going to make most sense to you once you get going with bigger and better circuits. They're all mathematically the same. They're all fine with me. I can tell the difference. And what I look for is consistency. If I look at your equation and I look at your picture and I say, okay, well, let's say we didn't have these words here. Let me cover that up. Let's say I didn't know that you were treating them as leaving the node. All right? So I would look at this equation, and I would look at the picture, and I would say, well, this one says I2 is leaving, and they chose to make it negative. So I'm going to expect these others that are also leaving to also be negative signs. If one of them was a plus sign, that's where I would say, okay, there's a problem with the logic here. All right? So I'm looking for these signs and these arrows to go together when I'm grading.